Hello, everybody. I and Jesse are super excited to be here to present our work up here, which is modernizing SAS workloads and moving them to Databricks. Do we have a click right here? Okay, yeah. So just briefly on the introduction, what we're going to do is we'll do quick intros, followed by me providing some context and background on the problem and the customer over here. We'll next dive into describing what the current state is in terms of the legacy stack and the challenges that it poses. After that, we'll get into describing our open source Databricks approach and solution, as well as the benefits. And time permitting, we'll leave some time for Q&A.
Hi, my name is Jesse Beaumont. I'm the CTO at Tensile AI. So Tensile AI specializes in healthcare data and analytics, and we have solutions that focus on value-based care, risk adjustment, FHIR, and patient engagement. And we also specialize in SAS migration for clients to Databricks and the Lakehouse. My background is in computer science. I have 22 years as a software developer, and many of those years were at SAS Institute. Many years as a SAS consultant as well in multiple industries. And we engage in various organizational groups to enable data science, promote adaptive data governance, foster collaboration, modernize system capabilities, and conduct training.
Thanks, Jesse. Again, my name is Uday Kumar, and I'm the Chief Digital Officer at Akira. Akira and Tensile are partners, delivering this work at CMS, which is Center for Medicaid and Medicare Services. Akira is a system integrator and solution provider to the federal government, and we're based out of Washington, D.C. Oh, we went one slide too far. That's fine. Okay. So just a little bit of context and background about the case study. The work that we're describing today is for a customer called CMCS, which is Center for Medicaid and CHIP Services, which is a division within CMS, which is Center for Medicaid and Medicare Services. Within the CMCS's mission is essentially providing oversight and operations and governance to the Medicaid and CHIP program that are currently being offered to about 75 million beneficiaries across 54 US states and territories. Within this program, there's a process called data quality measures. As part of this program, every state and territory has to submit a data file which has healthcare data every month to the mothership, which is CMCS. And this data is then used by CMCS to assess the quality, the outcomes, and the benefits of the Medicaid and CHIP programs. So then you can realize the criticality and the importance of the quality of this data. There's a process called data quality measures. This process is used to assess the quality of the incoming data from each state every month. And this healthcare data, again, comprises of things like demographics data, provider data, managed care, benefits, and pharmacy data. This whole process on the legacy stack was plagued with a lot of redundancies, a lot of delays. The states had to wait for about 2 weeks on an average to get a report on the data quality with the legacy stack. And then every time they had to correct those errors and defects and submit them, it was a full load. And so there was, again, we're going to talk about those challenges. And with that, I'm going to hand it over to Jesse to go into the weeds of the process.
Thank you. So data quality measures was a system of data processing that was implemented using base SAS with obviously data step and macro. And it was created by multiple contributors over generations of rules and policies. And the rules themselves were specialized in assessing details in beneficiary eligibility, providers, utilization, claims, and so on. So let's look at the characteristics of the code and identify those issues. So there was a list of problems. From the operations aspect, there were multiple contributors, and the end-to-end process took an extraordinarily long period of time. It was difficult to add or change measures as the policies changed or new ones had to be adopted. But at the end, they were not benefiting from the available cloud architecture and no longer able to efficiently meet the demands in a timely manner. On the technical side, it's difficult to analyze runtime performance metrics. There are artificial restart points to manage and monitor. There's no graceful exception handling into the code. There was unclear visibility into the progress of or data readiness, and the computing resources were shared amongst batch sessions. And there was an incapability for even parallel processing. And culturally, which is extraordinarily important, is that data assets are produced by siloed business units, and there was misconceptions as to the capabilities available to them with Databricks. And there was some resistance to change, which is understandable. Regardless of the qualities, it's a validated system, and it was functioning. So what was the ask? Well, Databricks was already available in their VPC. However, there were initiatives to undertake. They needed to leverage the capabilities of Databricks to the full extent. They needed to enable multiple analytic teams, and keyword on enable multiple analytic teams to contribute. Technically, the ask was to migrate the current SAS processes over to Databricks and optimize those processes to run in the cloud environment and apply open source and open standard technologies. Culturally, because of the impact, we had to provide a primer for optimizing legacy solutions beyond DQ measures and use modern practices and patterns and enable those existing teams to also maintain it because it was going to be reciprocated back to them. But there were some challenges. The current solution was written in a very procedural way, which is not atypical, and there was a lot of generic code that, given was being reused. Remember, SAS code has gone through multiple iterations, and like many procedural processes written in SAS, it included unclear data and code dependencies, overexpanded code for managing resources, which we will dig into more detail shortly. The metadata was blended in line with the processing code and the measure code. Data cleansing actions were scattered throughout. And ironically, there was a heavy reliance on pass-through. So the code that the macro was compiling and executing was dispatching ANSI SQL over to Databricks in a sequential manner. So why not just automate the conversion? It's code, right? And SAS macro is code generating code, and converters and compilers generate code from code. So let's revisit the automation option a bit. So some of the concepts are, well, I wouldn't have to start over. I mean, SQL just carries straight over, right? I mean, well, we know that's not necessarily true. Proc SQL allows some very trickster actions to go into the code. I should be able to convert the code in a short amount of time, right? And it's robotic, so if the human factor is eliminated and therefore we remove the miscalculations, right? Well, as you may know, that SAS has an extensive toolkit. And SAS coders are very clever, and there's certainly an appreciation for that. And you'll see here why we've listed many of the nuances intrinsic to SAS code. And if we did a conversion, the inefficiencies resident in the original code will be repeated just in the newer technology. So the approach was, well, let's first eliminate the need for any restart points, eliminate the linear flow, optimize the processes for the new platform, and then shift the culture. Get rid of those misconceptions that moving to Databricks meant recoding within notebooks themselves. Demonstrate where the benefits are and make it easy to triage and respond to issues, and create a pride of ownership in the new realm for those teams that will be maintaining the code. So we'll give an overview of the existing solution from the end user and their experience. So traditionally, there was an owner of a manual process. They would VPN to a VM. They would run a report in MicroStrategy to check to see if the new state submission of data had landed and if it was ready. Then they would flip over to a different VM, launch multiple enterprise guide sessions, which all share the same SAS app, and start the process to invoke the SQL queries using pass-through, collect the results, and stream it back to SAS to generate an Excel file containing each measure and the results. So this was quite a manual process that also required us a lot of expertise and familiarity in how to triage any issues. So we're going to zoom in a little. So with each measure that gets calculated by the process, we noticed a certain design pattern that was being done via pass-through. Temporary tables were being created. The query would get executed and populate that temporary table on the remote database. The measure gets stored, and the temporary artifacts are then torn down. And as this iterates, all of the measures were compounded into working tables that tend to compound in layers and layers and layers, and then that would get used to generate the final measure report. So you see in this diagram here, we have the SAS process running sequentially with a bit of a zoom in, explaining some of the housekeeping actions that were going on in the purple circle. But every one of those green lines behind that process was a different combination of measure parameters. And for those that are familiar with healthcare, healthcare can get very complex and it's not additive in nature. You have different behaviors you're looking at depending upon what the service category is, what the claim category is, and other details about the source information. So every measure was incomparable, for all intents and purposes, to any other measure. So creating any summary tables to do this in one swoop was near impossible because you were cross-sectioning data every possible way to gather interesting details that were actionable about the information. So we're going to zoom in a little further. This certainly does not do it justice, but on the left side of the screen, you'll see that there is a stack of code. And that is just a segment of the volume of measures that were run procedurally. Each measure refers to a healthcare claim category, and the categories were enumerated in source code. So you'll notice in the orange, there's enumerated categories that are denoted by a letter, and that's what I mean. This was the original code. And claim categories are significantly important, and there were 51 of them. And they pertain to whether or not it's Medicaid or children's health and some other aspects about the claim. So in order to prepare that information and carry them into the measure logic, what was being done is in the macro was generating a select clause that would transpose all of those columns into Boolean cross, but there was only room for one. So a lot of sparse information was being generated. That's a lot of I/O to push and pull. So there's also in the blue, you'll see a not missing one. What they had done in the original SAS code is they built themselves a utility library to look for things like regex patterns, missing data, so on and so forth. And we needed to look at that and realize that's important to them. And this all works, but if we're going to modernize their computing platform, let's be considerate of how things are going to snap into place on their behalf. And do not propagate those problems into the new system. So then we went into the modernization step. So just a quick overview. What is Databricks providing? Well, a lot, naturally, out of the box. We have job automation, visibility into performance. We have a unified platform. And so the process can be responsive to the availability of the new data per state, and those processes can be monitored for performance and tuned appropriately. So that way, which we'll look in another slide, every individual state could be calibrated depending upon the demand that would be expected of it. On top of that, it's really easy to integrate with Git. You have shorter runtimes. Obviously, we can introduce open source languages. And integration with other mediums such as Slack for notifications and automations were right there adjacent to the Databricks platform, and we took full advantage of it. So reflecting on the previous slide, this was kind of the thought process, is that we're going to dislodge the measures from the processing. So rather than have a series of macro calls that go one after another that are throwing different input parameters and each one exercising the housekeeping methods of building tables, populating them, and tearing them back down, we said, well, obviously, we should do two things. One, it should be data-driven, which is how a SAS programmer thinks anyways, but also the measures themselves should be first-order objects. So let's take the measure out of the process. Let's make the measures be fully autonomous as much as we can. So that's what we did to make this scale, at least a part of it. And instead of the sequential processing, we made the signature for each distinct measure a data point. And that familiar macro call for data validation, like the not missing, there were probably about 30 or 40 different utility macros they had. We looked at that and said, well, that's valuable because that's actually in their, not just their source code, but it's in their thought process. They like those macro names. They're meaningful to them to do these heuristic checks. So what could we do? Well, if we're going to be removing the SAS macro facility entirely, we should keep the namespace they're familiar with. After all, they will own this process in Databricks. And of course, Python supports lexical programming, and Databricks supports Python. So the items in green were actually built into a utility macro namespace, and as a courtesy to the people we took the code from and we're giving it back to, we provided the utilities as functional closures. And this is significant because the teams that were maintaining this code themselves can navigate to the new solution, and they can center on the data and the measure rules, not the framework and all of the scaffolding that was required to make it run. So fast forward a bit, this is the new version of a select clause that would be an exercise of a rule. So the select clause would go and query data, it would bring it back, it would profile it, would look for anomalies and interesting details about it. And it was a pretty verbose set of queries. But now that we've removed all of the underpinnings and allowed them to focus on the measure, you'll see that in the green here, we provided the modules that are now part of the Python library. And it's just SQL, right? Well, you know, the moment the modern solution does not allow a change, then it will, and the development teams cannot introduce any changes or new policies, two things are going to happen. One, it's going to start to diverge again with siloed code, as it's done in the past, or it's going to revert back to the original solution. So it's important to trust the data teams can code and enable them to extend and be proud of their work and influence. So what we did was create a Python library that could deploy to the clusters, including job clusters. And then the rule sets could be abbreviated down to, well, what is this rule measuring? And the modules themselves can be optimized by other teams. And those items in green were very good at hiding the complexities of system execution and dependencies. For example, DQ closure replaces the macro facility. DQ measures provided access to all the data dependencies without actually having to go and look them up. And the DQM metadata are all the cross-reference values for the different categories, like the 51 categories we looked. Here's sort of a beautiful side effect of working in Databricks with the Python library, is that when you encapsulate things in a nice, clean, object-oriented library, then if you're in the Python editor in the notebook, you can do control space and autocomplete. And now the API is telling you these are all of your moving parts. These are all of your data points that you can ingest and take advantage of the code. They did not have to go cross-reference code. It was sort of surfaced to them firsthand. So this is a very simplistic slide from the data scientist view. This is their new perspective. At the very top, they import the DQ measures library, and they prepare the notebook for a particular reporting period and a state. And when they call init, it runs through and it starts to manifest the collection of data dependencies that are now going to be in scope within the notebook. And that's all they needed to get started. So now that the individual measures are first-class objects, each one can be run independently and are no longer tightly coupled to infrastructure. And there was multiple ways to group them. And you can see why that's important in a bit. So in the first command, I just list a list of measures by name. So a couple fee-for-service, a couple managed care measures. In command 2, I could say I would like to run everything that is fee-for-service that pertains to inpatient stays. And then in command 3, I would like to run everything that was encapsulated in series module 901. That was something that was very important to the original team that developed it. What is also especially nice is that this becomes a sandbox to build a new measure, and that a new measure rule can be defined in the notebook right as an extension of the library in place without potentially polluting any information. All the available metadata and dependencies are in scope. Like I mentioned before, you have autocomplete. And this works really well for those that like to branch a code base and create pull requests and merge back into main. And any measure can be tested and modified in isolation. So let's go over the benefits here. Zooming all the way back out in the new modernized system, you'll see we laid out the data pipeline, and in the blue, green, and red are the actual modules we referred to earlier in the library. But now that measures are first-class objects and they can run independently, we could run as many parallel jobs as we saw fit. Computing resources can be calibrated specifically for states, such as California, that has over 12 million members, different than Vermont and New Hampshire. And that can sort of control the cost. And even subsets of measures can be distributed across parallel jobs as well. I mean, if you really wanted to, it would be possible to allocate a job cluster for every individual measure and run all 3,000 in parallel and get completed in a moment, if you really wanted to go that avenue. And this is a very important detail here that is critical to the solution. The rules and the measure output also did not use pandas. Pandas is wonderful. It's sort of intuitive for those that are familiar with DataStep. The problem is just the sheer volume of data and each individual measure's run. Just doing the collect action on it would labor the system significantly. So what we did is we just had Spark write directly to S3. And so it would fire the measure result and move on. So it was not appropriate to bring any of that data that was being assessed back into the Pandas data frame. It was appropriate to allow Databricks to optimize how the queries in the process executes as much as possible. So enable the system, let it do the work as it's designed to do. And what we really want to show you were the performance gains granted. So in the manner in which the solution was refactored, and also what was inherited from the Databricks platform, we're taking California as an example. So California has 12 million beneficiaries, and it's twice as large as the second largest state, that's New York. So the submission from the state of California to CMS for May of this year was over 300 million observations. And that also includes restatements of previous calendar months of claim data. So originally, the original SAS solution to run procedurally for the state of California would be in excess of 7 hours end to end for just that run. Now, given it's on SAS app and you have contention over the computing resources as well. So if you ran any multiple, it's probably going to slow it down. But by redistributing the measures to run in parallel allows it to run end to end. If you look at the average it would take to run of each module, it was just over an hour running in Databricks. And not only that, you didn't have to wait for it to get to a certain point in the code to present the log. You actually had the ability to monitor the resources at runtime, track costs ongoing, and that allows you to continue to focus on areas that need improvement. So in conclusion, back to the culture, right? These teams now have a unified platform with an open source API, and they could take full advantage of self-service. And this is where collaboration really should be, is that they interface with the API, they can utilize notebooks, they can build analytics, and they can perpetually deliver. And so back to these three areas, within the business arena, development of the measures by the data analytics teams is pretty clear cut. It's focus on the measure. You could expedite delivery to the states to give a response for any exceptional claim lines that need to be reconciled. You have adaptive data governance, so as things change, data changes, policy changes, it's obvious where to go look. From the technical point of view, it's straightforward to integrate new data. You reduce redundancy. You have all the visibility and performance. And this is the best part about it, is that culturally, that once they realized how straightforward it was to adopt. It really fostered collaborative development. It created a lot more community support, so we're using a lot of online documentation. We're capturing feedback via Confluence and Jira so that we can understand how to do support. We're using Slack for triaging issues. And there really has been a user acceptance and engagement from all parties, realizing just how wonderful it was to be in this arena. And most importantly, the states benefit with a faster turnaround and support for actionable items. And even more importantly, at the end of the day, the people benefit by allowing these teams to provide better health outcomes for the citizens themselves. Thank you for allowing me to walk you through this demo today. I have thoroughly enjoyed working on this project. And let me know if you have any questions that you could ask us afterwards. Thank you.
Okay, thank you so much. We have a few more minutes for questions, if anyone has any now.
Hey, great presentation. I'm actually with the CDC, so we have very similar problems on our end as well. Just curious about the timeline for this end-to-end migration. Is it still continuing, or are you done, and how long did it take?
Sure, I could give you an overview of the timeline. So we had a proof of concept. We broke it up by module. So I think there were officially 7 modules. Each module pertained to a different part of healthcare. So we attacked fee-for-service first, and because that had the largest volume of measures. Ironically, they were the most similar amongst themselves. We had that proof of concept up and running in a matter of weeks. And that sort of proved the layout to introduce module by module into the new design pattern. We were approaching final delivery after just a 6-month time period. And we went into user acceptance testing. The user acceptance testing, we actually built notebooks to automate looking at the output from SAS and the output from DQ measures, and actually did a comparison line by line, everyone. So there was a few weeks of going back and forth with their testers to verify that they were getting expected results. And then the great thing happened is that there were policy changes and there were new measures that now had to be introduced. So we sort of took turns. We went and implemented those new measures. It was because originally it was version 2.5 and then 2.6. That was the version on their measures. 2.6, I think there were only like 13 or so new measures that would be introduced. We coded them, and while we did that, we were thinking, okay, now I'm the other team. I'm the peers over at CMCS. What is the experience like? We designed the system. We're now introducing new measures. Do I like what I did to the system, right? So that helped create documentation and usability guides. And then just recently, we completely stepped away, and they introduced a version 3.1 of new measures. I don't even know what those new measures are. But I'm sure they have extremely competent and capable developers that are working on that project, but the list of questions has been silent. There's been a couple little things, nuances here and there, and they've invited us to do a review of what they've done and do a pull request. But from what I understand, that they deployed version 3.1 into production as of last week. And there'll be continued maintenance on that system. And it's indefinite because we're also looking at cost as it's executing.
And if I can just pile on to what Jesse just said, Jesse touched on this part of culture. And one of the sort of early requests that we had from our main sponsor at CMCS was that I'd love your team to model the right behavior right over here so that others can see, not just the CMCS employees, but also the other contractors that are out there can see the art of possible. So things like, we certainly want the hook to manage the scope, the schedule, the cost, but also sort of breaking these silos and these artificial constraints that had been there for a number of years, really showing great quality documentation and Confluence that was readily accessible to everybody. It's really democratizing all that knowledge that we had, having awesome run books. And then things like automation, like notifications, integrating all those runs to Slack. So as the engine's running, it's actually dropping these automated notifications so that all the engineers and all the stakeholders are fully aware where the process is, and if there's a disconnect, people can jump in and triage.
Yeah, I had a follow-up to the prior question. I guess just briefly, we're in health insurance and we do Medicaid, Medicare, so we're very familiar with quality measures. So I can imagine the scale because those things get pretty complicated. But I know you said 6 months to deliver, but I was curious in terms of the actual resources you had to put on the project over those 6 months.
Oh, that's a really good question. In the original group, it started with only 2 full-time resources that were just cutting through code as fast as possible and profiling it. And then as the feature set started to amplify, like he was explaining, in the latter months they were added to add automation. We added individuals to deal with the administration of the jobs, including deployment of jobs through a controlled, governed manner. But as far as the code conversion itself, it was a handful of individuals Sure.
One of the things that we've tried focusing on is making these processes well managed. So it's not just cutting things over, but also when it goes to operational state, that it has the right set of resources and notifications and things like that, so that when you want to maintain and operate it, it's efficient.
Hey, gentlemen, thank you for a great presentation. I was interested in the cultural change that you're talking about when you're introducing, taking some people that are used to SAS and moving over to, Databricks, Python, open source languages, right? Because I work for a pharma company that, SAS happens to be the gold standard for a lot of the, data modeling tools that are used to submit to the FDA. And, we have around 600 data scientists that work in our SAS grid platform, right? And so we've introduced Databricks, we're using it. We've got all the new folks that are coming on board are all into it and know Python and know R and they're ready to go. Did you have any kind of recommendation for, getting the groups that are SAS dedicated, haven't looked at anything else in their entire careers and get them over onto Databricks?
So your life sciences pharma?
Yeah.
Are you complying with CDISC standards like SDTM and those tables, ADAM tables? Okay, so, and also SDTM, to comply, at least what it used to be, it was SAS v5, right? Columns could be more than 8 characters wide. Right. And just understanding what that SDTM model looks like and understanding how to take your clinical data and populate it into that model and then do your ADAM, that's a lot of labor, right? So, my very limited familiarity with CDISC, right? I would say, because that is such a controlled, documented system, I would say that it'd actually be easier than this. What might want to take into consideration, and this is where I might be speaking out of turn, is like, how do you deal with, certain de-identified data that's a requirement or blinded information? And that's where I'm wondering if definitely would foster discussion with Databricks on how to control that. But as far as lifting the data in and doing the transformations, the advice would be stay in Spark as close to the hardware as possible.
You have trouble getting the folks to convert over, only used to using SAS?
Oh, culturally. So it, definitely. I mean, I've used SAS significantly in the industry, and I have appreciated it. It is really fun to use. And so I think what really helped was being able to understand the value in their individual code and appreciate that this is what they were trying to do and see from their point of view, and then show how it relates and being able to cross that bridge and sort of speak to them as if they're not at risk of losing all of their assets, right, was a really big deal. And I think compared to other languages like Java, I think Python is a better fit for SAS programmers because it has that functional nature to it, where you can write things lexically, you can write closures, and so I think that makes it a lot easier doing that sort of work. But running on Databricks, as far as an IDE is concerned, is just wonderful.
Round of a hand for our presenters today.
Thank you.
Thank you.